Okay, so in our last video, we introduced the idea of a radical. In this next video, we're going to probably talk about what's maybe is the biggest concept associated with radicals beyond just the simple definition. We're going to talk about rational exponents. Okay, so let's take a look at our learning objectives. They're pretty short in this video, and then we'll get started. We really only have two learning objectives. One is to be able to switch back and forth between something called radical form and another thing called rational exponent form. So we'll explain what those two things are, and then we'll talk about how to switch back and forth. And then once we know what those two things are, we ought to be able to evaluate expressions using those things. So those are our learning objectives. Okay, so what are these things? Well, radical form is what we talked about in the last video. So let's say that I have some random number, and since this can be any number, I'm going to use a variable. I'm going to use x, because it can be any number. It doesn't matter what number it is. And let's say I'm taking the third root of that number. Okay, well, one thing when it comes to rational exponents that you'll need to remember that's absolutely necessary is that although I can't see it, this x has an exponent. Okay, since we're going to be talking about exponents in this lesson, it's important that you remember that there's a sneaky hidden ninja 1 as part of its exponent. Okay, so that is going to be essential for you to remember. So a rational exponent says this: I'm going to take this thing and I'm going to rewrite it. So this is just a different way of writing it. These are equal. There's going to be my radicand, or my base is not going to, it's going to be the same. My radicand is going to become a base, maybe is the way to say that. And then I'm going to write an exponent here that is rational. And remember, the word rational means it can be expressed like a fraction. So rational is kind of like a fraction. So I'm going to have a fraction here. And here's the way I make my fraction. Whatever this exponent was, in this case it's a 1, the exponent will be the numerator of my fraction. And then there's my bar, and whatever the index is, the index, the number that's sitting on the little shelf, becomes the denominator. The denominator of my fraction. Now that whole fraction is in the exponent. That's why it's called a rational exponent or fractional exponent. The whole thing is in the exponent. And so this simply becomes a convention in mathematics that we say these two things are equivalent. It's just two different ways of expressing the same idea. So if you think back to the last video, we said that this represents the concept, what number, if I raise it to the third power, is equal to x in this case, right? I'd have to have some kind of number in here. Let's put a number in here. Okay, what number, if I raise it to the third power, is equal to 64 was the one we used in the last video. So I'll use that again. So from the last video, we know that this is equal to 4. And I can verify that on my calculator real fast. Remember, the way we did this before was we pushed the math button, option number 5. And then if I type in 3 and 64, there's my answer. Okay, so the answer is the number that when I raise it to the third power equals 64, that number is 4. Okay. Now, what this is telling me is that I could also write this exact same idea as 64 raised to the 1/3 power. 64 raised to the 1/3 power. And so that is, if it's the same idea, it should be equal to the same thing. It should be equal to 4. Now let's try that on my calculator. So remember the way I type in exponents. I type in exponents using the caret. So I'm going to go 64 caret, and then I can type in the fraction. Now we haven't talked about fractions before. Fractions are also in the math menu. I'm sorry, that's wrong. Fractions are in one of these menus up here. I think it's actually F2 menu. So I'm going to push alpha F2. I think that's where they are. Oh no, that's not where they are. Must be alpha F1. There they are. There's my fractions. So if I choose alpha F1 and I choose the first option, now I can type in a fraction. Okay? And so now I've got an exponent that's a fraction, 64 raised to that power, and notice the answer is exactly the same. So this becomes just a different way of writing the same idea. All right, so the nice thing with this, and the reason why we introduced this concept is, well, there's two reasons. The first reason is it gives me the ability to evaluate lots of different types of scenarios with regard to fraction or exponents and radicals. So let's take a look at a couple of examples of things that I would be able to do with this, okay? One thing that I would be able to do is to deal with something that has both an exponent and a radical. Something like that, okay? So let's suppose that I wanted to, well, let's do a couple things with this. Let's, first of all, just switch it into rational exponent form. Okay, let's do that first. Let's switch it to rational exponent form. So what we set up here is that the exponent becomes the top of the fraction. So in this problem, what's my exponent? My exponent is the 2. So that's going to become the top of the fraction in my radical, or my exponent. And then we said in this, the index, the number that sits on the lowest shelf, the index becomes the denominator, okay? So in this expression, what's my index? It's the 5. So that's going to become the denominator of my exponent. And then the radicand here, or the base of the power, whatever you want to think of this, that stays as my base. And so that's what it would look like if it was an exponent form. Okay, now here's the next thing that we were going to do. We're going to evaluate what this is equal to when x is equal to 8. When x is equal to 8. Okay. Now this I can do a couple different ways. First of all, I would want to plug 8 in, and we've talked about before, when we do that, when we substitute, we're going to always substitute using parentheses. So that's what it'll look like when I plug the 8 in. Okay. Now the next thing is I could try and do this a variety of different ways. I could try and do this without my calculator. So I'm going to figure out what 8 squared equals, and then I'm going to figure out what times itself 5 times equals that number, okay? It's going to turn out in this case that we can't find an answer. So I'm not going to try to do it by hand because I know, I just happen to know by looking at it that it's not going to work. So if I can't figure out the answer by hand, then I'm going to move to my calculator. And I'm going to try to do it on my calculator. And so there's a variety of different ways we could do this on our calculator. One thing we could do is we could type it in with the exponent. So I could switch this into 8 raised to the 2 over 5, right? Exponent over index, the 2 over 5 power. And then I could type that into my calculator. So 8 caret. So remember, to get fractions, I'm going to push alpha y equals is how I'm going to get fractions. So alpha y equals, and option number 1, okay? And then I'm going to go 2, use my arrow to move down, fifths, moves my arrow to move out, push enter, okay? Now remember, we said anytime we're working with radicals, if we get a decimal, that decimal is irrational. When you look at this, you say, well, I'm not really working with a radical, but remember where that fraction came from was a radical. So this decimal is going to be an approximation. This decimal is going to be an approximation, and it's going to be approximately 2 well, it's about 30, right? It's approximately, if I round this off, the 7 makes the 9 round up. If the 9 rounds up, it's going to bump into the 2. So I get approximately 2.30. Okay? And so that's one way that I could do it. Okay? Now, I said that we're learning these for two main reasons. One reason is because it gives us a method for typing it in. This is what I personally think is easier than using the math button to get the radical. We can still do it that other way if you want. We can still say, let's push the math button, choose option number 5, type in the 5th root of parentheses 8 parentheses caret squared. So I can still do this the old way and I get the same answer. But personally, I like to do it this way better. That's a personal reason. You might disagree, and that's okay. There is a second reason that we're learning these, and we'll see that second reason in subsequent videos as we start working with how to simplify radical expressions. Okay, so I think that's about it for this particular video. The main thing that you're going to want to be able to do is this first example, switching back and forth. If you can switch back and forth, then you're going to be in pretty good shape. The second learning objective, to evaluate, that's something that's a little bit a smaller topic because you can do most of that right on your calculator. Thanks for watching. Have a good day.